Alright, so here we're going to learn about the unit circle. It's a special, mythical, magical circle that you are going to love and cherish really for the rest of your life. First, we're going to focus on the degrees though. So, back up a second. If you've had geometry, you've seen these triangles before. If you haven't had geometry, maybe you've seen these triangles before. I don't know. But these are two special triangles from geometry. We call them a 30, 60, 90 triangle and a 45, 45, 90 triangle. They are really important to what we're going to see in trig as well, so that's why we want to bring them back. If you have seen them before, I want you to pause the video for a second and see if you can remember how to generically label the sides of the triangle. If you haven't, that's okay. Just hold on a sec and we'll come back and talk about it. You don't need to know this, but it is nice. So pause the video, see if you can label the sides, unpause when you're ready to discuss. Alright, so with the 30, 60, 90 triangle, opposite the 30 degrees is some value, and in this case we're going to call that x. But whatever x is opposite the 90 degrees is going to be 2x, and whatever x is opposite the 60 degrees is always going to be x root 3. With the 45, 45, 90 degree triangle, whatever is opposite the 45 degree angles, those have to be the same value, and again we're going to call that x. Whatever is opposite the 90 degrees then will always be what we call x root 2. Again, for right now, you do not need to know the 2x, the x root 3, the x root 2, the x, and the x for the 45, 45, 90. What I want you to more focus on is the angles that we're seeing here, right? So the 30 degree angle, the 60 degree angle, the 45 degree angle, and the 90 degree angle. That's what we're going to be focusing on today. The rest of the stuff is just kind of gravy for helping us later on in this unit. Moving on. All right. So, convert the degrees to radians. This is something that we did in the previous day. So I want you to, again, pause the video and convert 30 degrees, 45 degrees, 60 degrees, and 90 degrees into radians. And I want you to leave them as exact values in terms of pi. So go ahead and pause the video, see if you can do that, and use your notes from yesterday if you need to. Unpause when you are ready to check your answers. Alright, so just to refresh your memory, if you were confused what we did yesterday, so if I take some angle in degrees and I multiply by pi radians divided by 180 degrees, this will give me the same angle but in radians. So 30 degrees should come out to be pi 6th radians, 45 degrees is pi 4th radians, 60 degrees is pi 3rds radians, and 90 degrees is pi halves radians. Here you can see my work for the 45 degrees if you were confused, just to showing that with the actual numbers. So 45 times pi over 180 is pi over 4. And remember, we talked about using your calculator if you are not comfortable with the fractions to reduce 45 and 180, and that becomes 1/4, and then the pi is still there. Now again, I want to emphasize the same with the previous slide. Notice the 30, the 45, the 60, and the 90. Those are going to be really important angles. The pi 6, the pi 4s, the pi 3rds, and the pi halves, also just as important, but in radians. So now let's talk about the unit circle. Again, it's this beautiful, mythical, magical circle that it's one of my top 3 favorite circles, and if it isn't in your top 3 already, it will be by the end of the day. So first, depending on what our background is, we may or may not remember the generic equation for a circle in algebra, and it's x squared plus y squared equals 1, where this is telling me the origin is at 0, 0, and this is telling me the radius, because this is the radius squared. So again, if you have seen this before, it's x minus h squared plus y minus k squared equals r squared. You don't need to know that right now, but just trying to tie this into things that you may or may not already know, where hk is the center, r is the radius. So the unit circle is a circle centered at the origin with a radius of 1. That's why we call it unit, because it has a radius of 1 unit. So this is a generic blank picture of our unit circle. We're going to look at filling in the angles today. So we're going to start with the degrees. Now, remember those special angles that we were just talking about? The 30, the 45, the 60, and the 90? Those are going to be the first angles that we label after 0. So where is the initial side of every angle in standard position? It is at the positive point on the x-axis. So this is going to be our 0 degrees. Now, if I picture, okay, well, I know this, hopefully, is 90 degrees, right? So that's this angle here. Well, what are these three angles? Well, let's kind of temporarily just ignore the one in the middle, and let's focus on this and this. So if I can visualize now, and again, I'm ignoring this line here, so just pretend you can't see that. I know that's difficult, but sometimes pretending is fun, so pretend. So if I recognize that, notice that it looks as if I'm cutting this angle into 3 equal parts, or again, using a geometry term, I'm trisecting the angle, which means that this right here is 30 degrees. This segment would also be 30 degrees, so that angle is going to be 60 degrees. Now, if I go back and I go look at the one that I told you to ignore, don't ignore it, right? So I'm going to bold this in. So now if we focus on this and we ignore the green angles, well, this angle appears to be bisecting the 90 degrees. So what is half of 90 degrees? That's 45 degrees. Boom. Got it. So we just labeled the angles in degrees in the first quadrant. And just to emphasize if we're confused, so we've got 0, 30 degrees, 45 degrees, and 60 degrees. If you understand the first quadrant of the unit circle, you can easily understand everything else, because we also know the same idea of reference angles that we talked about. So if this right here is 30 degrees, this is also going to be 30 degrees. But that's not the angle that I want, that's the reference angle. What is the actual angle then? Well, the actual angle would be 150 degrees. That would be this, right? If the reference angle here is 45 degrees, what is the actual angle? Well, the actual angle would be 135 degrees. And then if we have this one here has a reference angle of 60 degrees, so then the actual angle would be this, is 120 degrees. And then hopefully we know, we have talked about this already, but halfway around a circle is 180 degrees. So what I want you to do now is pause the video, fill in the bottom half of the angles in degrees still, and then unpause when you're ready to check. Alright, so here I have the circle filled in. After 180 degrees, this is going to be 210, then 225, then 240, and 270. As we continue on, this is 300, 315, and 330. And then when we get all the way around, that same location as 0 degrees is 360 degrees. So remember, we learned that term yesterday also. Those are coterminal angles. Any questions? Okay. So now I want you to think about this. In terms of reference angles, what do you notice about all of the angles around the circle with the degrees? So pause the video, write something down, unpause when you're ready to discuss. Alright, so any volunteers? Excellent, very good. So we know that all of the angles have a reference angle of 30, 45, or 60 degrees. Right? And if we understand that, then it's really easy to fill in all of those angles around the unit circle in degrees. And now keep in mind, there's an infinite amount of angles on that circle. Those are what we call our special angles that we're going to cherish. Alright, on to the next video. Let's learn about the radians.